Now let us see conditions for destructive interference. We have the amplitude of the resultant wave is equal to 2a cos phi by 2. For the destructive interference, how do they destruct each other's interference pattern is, see this amplitude A, at the same time another wave will have the amplitude minus A. So if this is going in forward direction or upward direction, this is going in backward direction. So the angle between them is 180 degree or pi radian. So for the destructive interference, finally what happens is, after this the resultant wave will have the resultant amplitude 0. So you will get a flat line, so that no intensity is observed. When it is possible, when cos phi by 2 or the phase difference between the two waves should give you the value 0, that is possible when the phase difference between the two waves is pi, 3 pi, 5 pi, or generally it is a odd multiple of pi, which is 2n minus 1, where n is an integer, where n is equal to 1, 2, 3 and so on. Obviously we know the path difference then for destructive interference, the path difference delta is 2n minus 1. If pi, 2 pi is a path difference, 2 pi corresponds to path difference lambda, then pi corresponds to path difference lambda by 2. So this is a condition for phase and path difference of destructive interference. Now if we see the intensities, for waves of equal amplitude, what happens? R is equal to 2a cos phi by 2. So when phi phase difference is equal to pi, R is equal to 0. R is equal to 0. So the resultant intensity is 0 for equal amplitudes. Now for two waves of unequal amplitudes, say A1 and A2, what happens now? The resultant amplitude is root of A1 square plus A2 square plus 2A1 A2 cos pi it should be, because the phase difference should be pi. It should be pi. So this will be A1 square plus A2 square plus 2A1 A2 cos pi is minus 1. This is a square plus b square minus 2ab. So this is a1 minus a2 whole square. The resultant amplitude is a1 minus a2. So this is the case for two interfering waves with minimum amplitude. The resultant minimum amplitude will be a1 minus a2. So intensity minimum will be a1 minus a2 whole square, since minimum intensity is proportional to square of the minimum resultant amplitude. Now the ratio of the maximum to minimum intensity is, this is a1 plus a2 whole square divided by, this one is a1 minus a2 whole square. So a max by a minimum is a1 plus a2 divided by a1 minus a2 whole square. So if you keep dividing this by a1, then I max by I minimum is a1 by a2 plus 1 divided by a1 by A2 minus 1 whole square. This is another shortcut formula that we can think of. Similarly, for intensity, in terms of intensity, if you go by, then I is equal to, I minimum is equal to, I am going to use this formula again, that will be root of I1 plus I2 plus 2 root I1 root I2 cos pi, root I2 cos pi. So, I minimum then will be root of A1 square corresponds to I1, A2 square corresponds to I2. So, it is I1 plus I2 minus 2 root I1 I2, 2 root I1 I2. Rather 1 minute. Now this is intensity. Intensity means it is proportional to square of the amplitude. So this root will not be there. This root will not be there because it is proportional to r square. So this is r. So when I square it, this goes off. So it is I1, A1 square is I1, A2 square is I2, 2 into A1 is root I1, A2 is root I2 cos pi. So if we take the ratio in terms of their maximum to minimum intensity, the other formula is I max by I minimum is I1 plus I2 plus 2 root I1 I2 divided by, this is I1 plus I2 minus 2 root I1 minus 2 root I1 I2. I max minus I minimum, if you do, you are going to get 4 root I1 I2. 4 root I1 I2. Similarly, if you think of this formula, A1 square and A2 square, this is a amplitude and minimum is here. So this is about some of the shortcuts regarding the maximum and minimum intensity.